Welcome to this WiseOwl tutorial on working with files and folders in Python. Here's what you'll learn during the tutorial. So we'll begin by looking at the syntax of working with files, and then we'll do some examples of reading text from files. Then we'll see some of the other read commands you can use, which are possibly better. And then we'll look at using the with command to automatically close down any files you've opened. We'll look at writing text to files. And then we'll look at looping over files and folders, not just the folders, but also any subfolders they contain recursively down to the bottom of the hierarchical tree. We'll then do a much longer case study, probably the longest one we've done so far in this series of tutorials, showing not only how to loop over files in folders, but how to process each one you find. And finally, I just want to mention that there's other modules for working with CSV and JSON files, which you may find more useful, particularly for working with JSON. At the top right of the screen, as ever, a link will appear about now, and you'll be able to click on that link at any time to see all the files I've used for this tutorial and any exercises attached to it. But, as ever, I don't like being on screen, so I'm now going to hand over to Sven, who will guide you through the rest of this tutorial. So let's get started. So to work with a file, you need to open it. And the way to do that is to use the open function. And the open function looks like this. It takes two arguments. The first argument before the comma is the file path and name. So a typical thing you might put for this is something like this. The R at the beginning there signifies that you don't have to escape the backslashes, you can only include them once. The second argument is the code for how you're going to open it. And there's four main possibilities which are listed at the bottom there. W means you're writing to it. A means you're writing to it, but you're appending onto the end rather than creating a new file each time. R means you're reading only. And R plus means you're reading or writing to it. There are a few other options to do with binary files, but for the vast majority of people, that's all you'll need. The default is R. So if you leave the argument out, it will assume that you're reading the file. So with all that in mind, let's look at some examples. So what we're going to do is to use this file called bestfilmsever.txt. And what I'm going to do is read down the lines in it one by one. And I'm going to use this separator character to split each line into two parts, the number of the film and its name. Apologies for keeping using the same examples, and apologies if you don't agree with my films. So to do this, I'm going to go and create a new file. I've done it already actually, called readinfilms.py. And what I'm going to do is create a new variable called movies file, which will hold this file. So I need to put the word open in, and then I need to put as a first argument the name of the file I'm opening. I need to put a little R in front of that to say that I don't have to escape the backslashes. For my second argument, I've got two choices. I can either specify an R, meaning that I want to read it, or I could actually miss it out altogether, because if you remember, that's the default. And then I can press return to go on to the next line. So what I can now do is read through the lines in that. I'm going to create a variable called lines, which will take the movies file and read in all the lines. Although it's not actually quite that simple, as we'll see in the next part of this tutorial. What I can then do is loop over each line. And for each line, I can do something with it. So hopefully this next line looks very familiar. So for every line in your list of lines you've imported, what I'll do is create a variable, we'll call it bits, which will take that line and split it using the character I specified. So that will take the number of the film and then its name. What I'll then do is unpack this. Now, I've mentioned this in theory, but I think it's the first time we've done it in practice. I'm going to create two variables. The first I'll call the film number, and the second I'll call the film name. Sorry to keep switching between films and movies. I don't know where I am, which side of the Atlantic. So what I'm going to do is take the bits list and split it. So I'm relying on the fact that when I open up a line, or when I process a line, there's only two parts to it. The first part will be stored in a variable called film number, and the second part in a variable called film name. So what I could now do is just to prove this works, is to print this out. So to do that, I'll print out, and I'm not going to do anything particularly imaginative with this, I'm afraid. I'll just print out the 2 bits of information which I had in the first place. There's one more thing I need to do, and it's crucial. I need to close the file. It's very bad practice to leave files open. Eventually Python will come along and automatically close the file, but you can't rely on that happening, or indeed when it does. And later on in this tutorial, I'll show you a way to make this error history by automatically closing files when you finish working with them. But for the moment, we need to actually close it. So I'll use the close method. So let's see if that works. If I now try running that file, you can see it gives me almost what I wanted. I've just got a bit of a trailing backspace problem. So what I could do to get rid of that is just when I'm printing out the film name, I could strip it of any spaces. And I'll just try running that one more time, and you can see it gives me the information I wanted. So that's basic reading. So what we're going to do now is to look at the different ways in which you can read lines in from a Python text file. So one way is to use the read lines method. We've used that already. If you put a number in brackets, what that represents is the suggested maximum number of bytes. So basically, once it looks like it's going to go over the maximum number of bytes, it will stop importing lines. I have no idea why you'd want to do that. Similarly, you can use the read method, and what that will do is read in the entirety of the file. If you specify a number of bytes, it will stop at that number of bytes, so it will only possibly useful for when you're loading a massive file and you want to buffer it and do it in chunks. A third option is to use the read line function. And what that will do, as you might imagine, is read in one line at a time. But the fourth and final option is by far the best one, which is don't use any of these. There's a much better way to read lines in a much better syntax, and I'll show you examples of all of these, including the last one, in a second. So going back to our example, let's have a play about with it to see what the different functions do. I'll just comment out the main body of this text, and then I'll make sure that I'm actually printing something out by printing out the lines there. And just to remind you what we get at the moment, it will show read all the lines into a list and display that list. If I wanted, I could put the number of bytes in there. So if I put, for example, 70, what it would do is stop reading when it thinks it's going to go over 70 bytes, and I get the first 3 lines. So that's what the read lines function does. Let's look at the read function does. If I put that in and run this, the read function, or read method I should say, reads in the entire contents of the text file. Again, I can put in a number of bytes, let's put 42 this time, and I'll get exactly 42 bytes worth of information. So that's what read does. The third one I mentioned was read line, and read line is used most commonly when you want to loop over the lines of a file, reading them in one by one. So if I run this, I will just get the very first line in the text file. If I ran this command again, I would get the second line and so on. So I promised you that none of those were the best ways to do it. So which one is? Well, let's just get rid of these lines, and let's reinstate these lines. And this is the best way to do it. What you can do is take the name of the file and loop over that. And the default assumption that Python will make is that you want to loop over the lines one by one, which is always exactly what you want to do. So if I run that, I get the same output as I did previously. So not only is this easier and quicker to write, it has one other advantage too, which is this is a generator. Now what a generator means, without wishing to go into too much detail, is it makes no assumption about how long the file is. So what it will do is start at the beginning and keep reading the lines one by one, remembering where it was each time around the loop. You can see some justification for this on this Stack Overflow article, and I've put a link to this in a useful files text file, which you can get to by clicking on the link at the top right of the screen. So this is just a bit of an explanation which you might like to read, explaining why this sort of loop is actually the quickest way to loop over the lines of a text file, and that's the one we're going to use from now on in this tutorial. So having improved the way we read the lines from a file, let's improve the way we open it as well. This is the best way to open a file, whether you're reading or writing. You can use this statement. With open the file as, and then you specify the name of a variable by which you want to refer to the file. What you would then typically do is loop over all the lines in the file and then do a number of different things. The crucial point about this is once this block of code has finished executing, Python will automatically close down your file. You don't need to worry about that. So once you reach this point in the code, there's no way in which your file can still be open. It's just one less thing to worry about. So let's see how this works in practice for our example. So I'm back to our usual example here, and what I'm going to do is change it to make it optimal. So I'll just copy that to the clipboard because I'll need it in a second. And I'll say with, open that file as, and then I'll put in here the name of the variable. And then put a colon in. Python will immediately start complaining because I need to indent all this code. So I can select it all and press the tab key. I no longer need to close the file because that's going to happen automatically. In fact, that line of code would crash if I left it in. And those are all the changes I need to make. So it will automatically open the file, loop over the lines, and then close it back down again. So let's try running that. And it works exactly the same way as before. So we've read in the best films from a text file. Let's write out the worst films to a text file. Now, worst films is clearly a subjective consideration, but my colleague Andrew would definitely say that Titanic and also Twilight are the worst films ever made. You only have to read his comments in his movies database to see this. He's quite passionate about the subject. Personally, I think Titanic was okay. It did go on a bit though. What I'm now going to do is to create a file and write out to it. And the syntax for doing this is almost exactly the same as for reading it. So I can say with, open. Then I can put in the name of the file in quotation marks. I'm going to call mine badfilms.txt, and I've chosen my folder. I'll need to put a little R in front of that, so I don't have to put an escape character before the backslashes. And I also need to specify a second argument, because by default it will assume I'm reading, so I'm actually writing to it. Then I can put as, and then I can put a variable name, so I'll call it bad file, and then colon. So then I can write out some lines. So I'll start with the title. And to do this, I can take my variable name called bad file and use the write method to write out a title. Now I'm going to put a question mark after that so I don't lose all my viewers. So the next thing I might want to do is write out my worst film, which is, as attention mounts, Home Alone. So apologies if you enjoyed it, I didn't. And then I'll write out Andrew's. And to do that, I can put badfile.write lines. And what this will do is take any iterator, and I've got exactly what I need. I've got a list, so I can just provide worst films there, and it will automatically loop over all the items in the list, writing one line for each. Finally, when I get to this point, it will have closed down my file. But I'd like to see that everything's worked okay, so I'm just going to say done there, so I can see my program has finished. So now what I could do is try running this file, and it says done, which is a good sign. And if I go to look at the file called badfilms.txt, you can see it kind of worked. I thought I would get different lines. I was expecting write lines to write lines, but it appears that Python doesn't actually do that by default. So to get my line breaks, what I'm going to have to do is add them in manually. I'll have one after the title, one after Home Alone, and one after each item in my list. So you can do that by putting join in like that. If I run this program, you should see that I get the same done message, but if I go to look at the file, I've got line breaks after each one. Perhaps the only other thing to mention about writing information to a text file is that I could have changed my W to an A. And if I do that and run the program, I get the same done message. But when I double click on the file to have a look at it, you can see it's appended the items onto the end of the list of films. So that's how you can write information out to a text file using Python. You can loop over files in quite a few different ways. You can use the OS module and use the listdir method, or the scandir method, or the walk method. The one we're going to use though is the glob module. And I think this illustrates a common problem with Python. How do you know you've got the best module to work with? Sometimes it's really obvious, sometimes less so. And I think what you're probably going to have to do in this case is trust me to have chosen the easiest one to work with, but by all means experiment with some of the others yourselves. So what we're going to do is write a program called loopingoverfiles.py. I've created it already, which will use the glob module to show all these files. So I've got a folder which I've been using in this tutorial, and I've got the 4 files I built up already, including the one containing the program we're about to write. So that's a bit self-referential. There's also another folder within that, and if I go to that, that contains another program and yet another folder, and that contains 2 more Python programs. So the first draft of this program will just list out the files in the folder, but then I'll show you how to change this so it loops recursively and shows any files in subfolders and their subfolders until it reaches the bottom of the tree. So to get this to work, the first thing I need to do is to import the wonderfully named glob module. And then what I can do is set a variable. Let's create a comment, create a variable. And what it will do is hold the list of files. So we'll call it files, and I'm going to set it equal to glob, which is a module, and then call the glob function as well. As always, I wonder what else is in that module. I always wonder this about modules. Don't claim to know everything. So we're going to put the letter R in as a prefix, and then paste in the path which I happen to have in my clipboard. And the letter R, as always, avoids the need to escape backslash characters. So that will automatically return a list of my files. Is it a list? Let's find out. It is. It's a list, a list of rather strange things. I think these are strings by any other name. So what I can do is loop over the files. For each file, I can say, for file in files, I can just print out its name. And to get its name, I can just print file out. Now at the moment, I'll just get a single folder when I run that, and that's because I've forgotten to specify a file specification at the end of this path. So what I'm going to do is show all files with a py extension. You can use a star as a wildcard. So that will mean any files ending in .py. So it will omit that text file. So let's see if this actually runs. If I now try running that, you can see it gives me a list of my 3 files. Now, if I want to make this recursive, what I can do is make 2 changes. One of them is obvious, one isn't. Incidentally, you can use, instead of a star, you can use a question mark. So if I were to type in 13 question marks, I've counted this before, it would give me just the one file, which is a file called readinfilms.py. And that's because that's the only one where there's exactly 13 characters in the file name. But I'm going to get rid of that and replace it with just a star because I think that's more useful. So yeah, we need to make 2 more changes to make this loop recursively, including all the subfolders and their subfolders. The first obvious one is to add a second argument. It's called recursive, and I can set that equal to true. I think it came in Python 3.6, somewhere around there. So if you're using an older version of Python, it might not be available to you. All the more reason to upgrade. So if I now try running that, then you can see it lists all the 3 films, or the 3 programs rather, but it doesn't loop recursively. And the reason for that is you need to say, I want to loop over all the files and their subfiles. Why sticking *** in before the end of the path works, I'm not actually quite sure, but I'm just a realist with these things and I know it works. So now if I try running that, you can see that it lists out not just the programs in that folder, but also in their subfolder, their subfolders and also their subfolders too, until it reaches the bottom of the tree. There's always a danger when learning any programming that you'll learn all the techniques but won't be able to chain them together to do anything practical. And to help mitigate against that, what we're going to do is a much longer case study. In the files attached to this tutorial, which you can get at by clicking on the link at the top right of the screen, are 3 CSV files, countries 1 to 10, 11 to 20 and 21 to 30. And each of these contains a list of countries. So if we open up the first one, for example, They all contain the same header, and then they contain in the first 10 countries in size order. The next one contains the next 10 countries in size order. And the final one contains, and you probably guessed where I'm going to go with this by now, the next 10 countries in size order. All of these, by the way, came from this website, which lists out the largest countries in the world by area. If you want to see where the UK is, I think the answer is a pitiful 80. And I've included the link for that in the usefullinks.txt file accompanying this tutorial. It's there. So what I want to do is to be able to read all those files in, print the titles out once and once only, and then list out the first 10, second 10 and third 10 set of countries to get the output. To do this, I'll just shut down these two files now. I've created the outline of an algorithm in a file which I'm going to use called listing contents of 3 files.py. So I'm going to create a variable to hold the list of the files using the glob module. I'm then going to sort them into file name order. That's actually quite hard to do, and I'll probably leave that right to the end. We'll then print out the title for the output. So that's the very first line, giving the number, the country and the area. And then we'll loop over the files. For each file, I'll open it up for reading. I'll just show you how to get the file name and file path for debugging purposes, although strictly speaking we don't need them at this point. And we'll get all but the first line. I don't want the first line because that's the one which contains the titles, so I want to miss that out. And then we'll loop over each lines one by one, and for each one we'll split it into the number, the country and the area and print each out nicely aligned. So that's my plan. There's a fair amount to do. So this will be by far the longest section of any tutorial I've done so far. So I guess let's get started. So the first thing we'll do is import the glob module, without which we're not going to be able to do anything. And then I'll create a variable to hold the list of files. So to do this, let's call it files as before. I can do glob.glob. And then in brackets, I'm going to specify the file path. And I'll get that by just copying that to the clipboard. And then if I go back to Visual Studio Code and paste that in, I then need to put **, because if you remember, that's what allows me to do recursion properly. And then I put star.csv. Incidentally, to make sure I do need to use recursion, let's make this slightly harder. Let's cut that, create a new folder, which I'll call temp. Just paste it in there. So you've got one of the files is in a subfolder, just to make that life that little bit harder. So then the next argument I'm going to put is recursive and set that to be true. And that should ensure that I get all 3 files. The thing to do when programming is to keep testing out your work to see if it's actually working, rather than going all the way to the end and finding there's a fundamental problem at step 1. So what I should now be able to do is to print those out. You'll notice I've abandoned my shortcut key demonstration for the moment. And you can see it's listed out the 3 files, although they're not, I think, in the correct order. We've got the first one, then the third one, and then the second one. But it's a good start. So we'll just copy that to the clipboard for the moment. So the next thing we're going to do is to print out a title for the output. So I want everything to be nicely aligned. So what I'm going to do is print out this message. I'm going to start with the word number, but I'm going to center that across, let's say, 20 characters. So what the center function is doing there is taking the text which precedes it and allocating 20 characters width to it and center aligning it across that width of 20 characters. It's a standard way to make output look nicely aligned. So the next thing I'll do is take the country, and I will center that across, let's say, 50 characters. And then finally, I will put in the area. And I want to right justify that just by way of variation, and I'll leave 20 characters for that. So if I run that, you'll see it will give me my 3 headings. There's about 20 characters there, about 50 there, and about 20 at the end. So what I'm now going to do is loop over the files, and for each file, I want to do something to it. So I can say I'll call it file again in files, and that will do that. What I now want to do is to open each file for reading. So to do this, I can say with open. The only thing I need to put in here is the word file. As I loop over the files using glob, it gives me the full file path, the folder and the name from there. And that's exactly what I want when I want to open a file. So I can just put with open file. I'll call it this file. What I'm now going to do is to get the file name for debugging purposes. And to do this, I'm going to use the rpartition function. And it's probably going to help if I could just quickly remind you of what the files look like. So when I print that out, that's because I haven't yet done anything. So what I'm going to do is add the word parse in there. I don't think we've seen the word parse before, but what it is a placeholder. It means run a statement. It was giving me a compilation error because there was nothing following in the loop, so it couldn't actually make sense of it. But if I now try running that again, you can see it gives me the file path. So what I want to do is to take each file path and split it by the final double backslash. And as a reminder, this is a reminder of two things we did earlier actually. I'm going to unpack a list. So I'm going to create three variables, which I'll call file path. The second one, I don't care what I call it. I'm going to call it an underscore, which is a common convention when you have a variable which you don't care about and aren't going to use. And the third variable, I'm going to call file name. And I'll set that equal, well, I'll take the file and then I'll right partition it using the backslash as a separator. If you remember what the rpartition function does, it splits something into three parts. The bit before the separator itself, and the bit after the separator. So the bit before the separator will be stored in this variable, the separator itself will be stored in that, and the bit after the separator, giving the file name, will be stored in that variable. And just to prove this works, let's actually print these two things out. So if I print out the file path, and then print out the file name, and if I now try running that, you should see it gives me the file path, which is there, and then the file name, which is there. It doesn't give me the separator between them. It's all going swimmingly. So the next thing I'm going to do is comment that line of code out, because I don't actually need it. That was just for demonstration purposes. And now I want to get all but the first line. Now I gave you the advice previously to just say for line in lines, or for line in file name, but I'm actually going to do something slightly different this time. I'm going to create a variable called lines. I'm going to take this file. I'm going to apply the read method, which will get absolutely everything from it. I'm going to split those into lines. So I've now got a list of all the different lines. And I'm going to ignore the first one. So I'm going to slice from the second one right to the end. So I'm hoping that will give me a list of all the lines, but the first one, there's nothing like a bit of testing to see if this is working. So if I print that out, you should see, you can just about see that in each case it's missed out the first line. So there's the first line of the actual data for the first file, for the second, and for the third. Comment that line out again, or remove it altogether. So now what I want to do is loop over these lines. So to do this, I can say for line in lines. It's easy enough. And for each line, I want to split it into the number, the country, and the area, and print them out. Well, I know that I can use a comma as a separator to get the three component parts of this. So I'm going to use unpacking again. I'm going to create three variables, which I'll call number, country, and area. Why not? And take the line and split it by the comma delimiter. Providing my lines are always in the right format, that should work. It should divide it up into the three different parts. All that remains for me to do now is to print that out. So to print it out, I'm going to start with a number, but I think I need to convert that to a string of text to ensure it's treated as a string before I send to justify it, assigning the same number of characters as I did at the top. I can then concatenate that, and the next thing I want to do is put the country, And what I'll do with this is again center justify that across 50 characters. And finally, I'll put the area, which I will right justify over the last 20 characters. Wow. Okay, so there aren't any deliberate mistakes in this, but there's probably accidental ones. But let's be brave and try running it. That's not bad. I've left a little bit of debug in there, which I'll take out in a second, but otherwise it does actually seem to work. It's just the sorting which is a problem. I haven't got them in the right order. So as promised, I'll just take out my debug there. Run it again. So all that remains for me to do now is to sort the films into the film name order. Now this is very much an extra. And includes something called a lambda function I haven't covered because I can't actually think of any other way to do this. In theory, I just want to do files.sort. But if I run that, it doesn't actually solve the problem. And the reason it doesn't solve the problem is it's sorting them by the full file path, the contents of it, whatever that may be, not by the file name. So, as I say, stop now if you want. But this is how to get the sorting by name working. So think of this as a bonus. So I can set the key equal to, and then I'm going to use something called a lambda function. Now I'll do a proper tutorial on these later. For the moment, it's just a way of solving this particular problem. I'm going to use the variable x to refer to each of the elements in this list. I could have used any variables I like, any variable name I liked. And what I'll do is take x, and instead of using x, I will I'll right partition it. That will split it into 3 parts. The bit before the final backslash, and the bit after the final backslash. And what I want to do is split it by the last one of those 3 things, the file name. So to do that, I can specify -1, which will give me the third and final part. Let's see if this works. And if I try running that, you'll see it gives me the data in the final output order. So just before I finish this tutorial, I think it would be incomplete if I didn't mention that reading and writing, as I've shown you, isn't always the easiest way to do anything. If you're working with a CSV file, I've just processed one of those in that case study. But there's actually a separate CSV module, and what that makes it easier to do is to read your data into a dictionary. And I'll cover that in a later tutorial in this series. If you're working with JSON, it's much easier to use the JSON module, because what that would automatically do is to deserialize and serialize the data and store it in Python objects. If you've no idea what I'm talking about, you will do when you get to grips with JSON. So that'll be a subject of a later tutorial too. And the only reason I mention those now is I would hate anyone to sweat trying to get the CSV or JSON data out of their files when there's a much easier way to do it coming up later in the tutorial series.